Yeah, hi and welcome today to our webinar, Laser Scanning in Practice with Riegl. I'm very happy this wouldn't be a good Riegl webinar if we wouldn't have a Riegl user and someone from actually Riegl here. So please welcome with me today Nikolaus Studnicka from Riegl and Mathias Ganspöck from I think EKG Baukultur, German pronunciation is fine, I guess, who's a Riegl super user and will today, the two of them will show you a larger project, how you get that done with Riegl scanners and how you make it work. So with no further ado, I want to give the word over to the two of them. So that's it for me. And thank you. So to you too.
Thank you very much, Nicole. May I introduce myself? I'm Nikolaus Studnicka, working for the company Riegl Laser Measurement Systems in Austria. I'm sitting now in Vienna and welcome you to our webinar, Laser Scanning in Practice with Riegl. Matthias Ganspöck is the founder and partner of the EKG Baukultur, and he will speak after my presentation. Actually, I want to present also his project from the beginning. So the first statement is, in one working day, a surveyor can record hundreds of scan positions with a terrestrial laser scanner. He can register the data, georeference it, and export it as homogeneous point cloud. So 2-3 years ago, it would not be true what I'm talking about. But I want to show the different development steps why it's possible for today. After a very short specification of our laser scanner, Riegl VC400i, I want to give you some basics information of the automatic registration. The block adjustment of many scan positions, we call it multi-station adjustment. The new one-touch processing wizard, and the project we show you is in Millstatt, in Carinthia, in Kärnten, in Austria. So the laser scanner has a range of 0.5 meter to 800 meters with a precision of 3 millimeter. And for the standard scan pattern, we choose an angular resolution of 40 millidegree. What does it mean? It means in 10 meter distance, you have a spatial resolution of about 7 millimeter. The specialty of this family of laser scanners, it's not only the VC400i, it's a VC2000i available as well, with a maximum range of 2.5 kilometers. The specialty is the speed. So we can take 50 scans per hour together with photographs if the camera is attached on top. The field of view is 360 degree times 100 degree. So altogether, sorry for the German word on top, 50 scans per hour means 400 scan positions in an 8 hours working day. So that's possible, easy possible with our laser scanner. And while scanning, the scanner registers all these scan positions together. And it can also register the scan positions without any light and without any GNSS reception. Parallel to the laser scan, high resolution photographs are taken on top if the lighting is sufficient. If not, we take the pictures after the laser scan. Then it takes a little bit more longer. During scanning, a floor map can be displayed on the mobile device. I will show you 2-3 slides about that. And with the new one-touch processing wizard, it's possible to automate all the different tasks I will show you also. So Millstatt Abbey is a former monastery in Millstatt am See in Austria, and EKG Baukultur got the contract to scan. And what you can see on the left side, where it's located in Austria, on the right side, I hope you can see the details. Every single spot is a laser scan. So there are so many dots on the top view. So they scanned in 5 days the whole area, and you will see the yellow part is in detail, so in several floors, and the blue is there are some because of some planning for roads and so on. But what you can see, the first scanning day with 400, the second with 300, 300, 300, 300 scan positions in total. It's a scanning project of 1,692 scan positions. We recommend a project in RISE-CAM Pro in the software for our laser scanners of maximum 1,000 scan positions. But yes, it's possible to have also project with more of 1,000. But then you have to use also several projects. If we look from the top, you see how many scan positions in different levels, in different floors. What you can see is an X-ray view. So there is no color, and you can look through the ceiling of the different buildings, and you see how many scan positions are possible in a 1-week project. What's the difference between the X-ray view and the true color view? So on the left side, it's an orthogonal view from the top. On the right side is the true color in the perspective view. So, but it's absolutely the same data set. So we can jump from one view to the other easily. So that's the project, and we want to see how does it start. That was scan position number 3. So you see a point cloud of a single scan position. The gray coded image is colored by the so-called reflectance, which is an intensity, which is range independent. The scanning time is 45 seconds, and in one single scan, you get about 22.5 million measurements. Angular resolution, as I told you already, 40 millidegrees, it's 7 millimeters in 10 meters distance. And you can also get the images from the camera, which is on top in parallel. That means for this scan, and with a Nikon, for example, Nikon D850, I think the maximum exposure time is about a 215th of a second, because we do not want to have the blur effect. But so the aperture of 8 is fixed, and what we change is the ISO sensitivity of the camera setting. So you see the colored point cloud. One image which does not contain to this project is the St. Stephen Cathedral. You can see a project of 1,000 scan positions in one single image. But what you can see, it's also possible with the attached camera that we take pictures indoor in low light conditions, but then it's not at the same time as we scan. So we make one scan after the other, and after the motion of the laser head for scanning, we take the pictures. but with fixed settings of the camera. One task is registration, which is one of the most difficult tasks, and we had a lot of development in the last years exactly on that. So what does it mean, registration? It's a determination of the 6 degrees of freedom of the last scan position in relation to the previously recorded and already registered scan position. Another task is the so-called block adjustment. We call it multi-station adjustment. So this happens after all the scan positions are registered. So there is one step where you modify all the position and orientation of all scan positions. And in this step, in this task, it's possible to use control points if necessary. I want to show you the registration process as a block diagram. So at the beginning, you have a scan. We know more than 20 million points per scan. And the onboard registration means that we step by step, we bring the scans together inside of the laser scanner. The first step is to create a voxel data set out of the laser scan. Some few hundreds of voxel per scan position in one voxel data set are used in the voxel registration. After that, we have an accuracy of the registration of in the centimeter range, but they are almost perfect registered. In the next step, we use the ICP, a modified ICP algorithm, to reach the millimeter accuracy of the registration. Outside of the laser scanner, so we upload the data from the scanner to the computer. We start the multi-station adjustment, which modify the position of all scan positions. In preparation for registering a new scan position, a regular data set is derived from the point cloud and that's called the voxel dataset. I show you one example in the next slide. Here, a voxel represents a multitude of points of the point cloud. This voxel data set can thus be understood as a spatial signal and represents the basis of a transition from the spatial domain into the spectral domain via the Fourier transformation. So if you want to know about that, there is the reference vollautomatischer Ansatz für die Onboard-Datenregistrierung, and that was published in Fulda 2017. So this registration method, we call it spectral registration, is very, very robust. So at almost every single project, it's working perfectly. So the voxel data set looks like that, but the voxel size you can change. If you are indoor, we use smaller voxel of 5 centimeter length of each side. Outdoor non-urban, we use 50 centimeter, and in mining area, 2 meters or 4 meters. So we are using 265 voxels in each direction, and this goes through the Fourier transformation. But before we calculate the principal component analysis, that means for every single voxel, We calculate the plane inside if there are minimum 3 measurement points with a normal vector. To further increase the robustness of the method, independent sensors are used. For example, for outdoor application, we have a GNSS receiver. It's also possible to have an RTK solution. We have accelerometers for rotation around the X and the Y axis, a magnetic compass. The data is not as accurate. And very important, a small IMU. So from one scan position to the next one, we should repositioning the scanner within, let's say, 20 to 30 seconds. So then we have a good solution to start the registration process. We have also a barometer if the GNSS altitude is not accurate enough. You see one scan now as 2D representation. And what's important is that every single scan outdoor has its own GNSS coordinates. And because there was a correction signal through the internet, either you use the SIM card or you use your mobile phone as hotspot, you get an RTK fixed and you get an accuracy of less than 2 centimeters for each scan positions. So for sometimes this is absolutely good enough for the georeferencing of the whole project. Be careful, it's not the accuracy of the registration, which is millimeter accurate, but the whole project can be shifted some few centimeter. Of course, you can use also control points. With our GeoSys manager, you can select the right geoid model, the different coordinates systems, and for importing the control points, for exporting the data, it's possible to use the coordinate. The standard coordinate system of all our scan data is the WGS84 geocentric. Now you see one scan position and all the scan positions are registered already in the scanner. So the data will be merged already in the scanner before uploading the data into the computer. A specialty of our VCI laser scanners is that we allow the customer to write its own apps. It's a Python app, and so you need a Python script, a logo, what you can see on the screen, and a short description. So we can upload these small apps into the scanner. There are some standard apps which you cannot adapt, but you can also modify the apps by yourself. One standard app is called the Project Map app. On the right side, you see the scanner in a garage without any GNSS, with low light conditions. And you see, while scanning, you can see the top view of the garage, and all the blue dots indicates the scan positions. What we are doing here is we show you the so-called project voxel. So the voxel data set is growing with each single scan position. A new development is the anchor scan position. So for example, you start with the scan position 1 and you go in one direction. So every 10 meters you take a scan, you are at scan position 10. It is possible to jump back to any already registered scan position. So you enter in the GUI, in the graphical user interface, that you are standing now at the scan position 1, which is already registered. and then you can walk in the different direction. So that means that indoor you can jump back, for example, in this example, about 100 meters, and you can scan in a complete other direction. In Rescan Pro, it's indicated by an anchor. So the scan position 54, for example, is exactly on the same position at 46. So there is no need to move the scanner within the 20-30 seconds from one scan position to the next. And even there is no GNSS, we can give this information to the scanner in the field. So this is the one-touch processing wizard. Starting with task number 1, it's easy to import the scanner project. So we convert the scan data, which is optimized in the scanner to have a very small data file to another Riegl database, which is optimized to have a quick access. In this case, we processed 292 scan positions, and the processing time for all the tasks was less than 5 hours. If we filter the scans, we filter by the reflectance. So we use we do not use very low reflecting and super high reflecting targets. And we have deviation. So that's a parameter which allows us to eliminate points which are so-called ghost points between two different targets. Deviation means how good is the shape of each laser pulse which we receive. So if you hit a white wall, then the laser pulse shape is very similar to the laser pulse which we emit. So that's a good point. But if you have different targets, for example, in vegetation, then the laser pulse shape is completely different, and we eliminate these points. The next step is register the scan position. So you can see it's in 6 seconds because all the scan positions in this case were registered already in the scan. The fine adjustment means the multi-station adjustment. So we modify all the scan positions to reduce the maximum error, to have a good overlap between the different scan positions, and we can use also the control points. We can modify the mounting calibration of the camera, which is the external calibration. We keep the internal calibration of the camera fixed, and afterwards we can colorize the scans. In the task number 7, we are able to create an octree-based point cloud, in this case with a 1 centimeter distance between 2 points, in order to homogenize the point cloud with an average distance between 2 points of 1 centimeter. We can create 3D views, auto plots, and I hope Mathias will show you an example of the Panos, which is the project you can export also into the internet for a fast access of the whole project. Control points. We are using the so-called Riegl reflectors. These are retroreflective B-reflex targets fully automatically. But we can also use manual detected black-white targets, as you can see on the right side. And usually that was a project in Vienna of a bridge with 300 scan positions. We have an accuracy in XY of less than 5 millimeter and in the set value of less than 7 millimeter. So we try to have all our projects better than 10 millimeters, but not only the single scan, it's the registered project. So I come to my end. This is a substation, and it was also scanned by EKG Baukultur. You see how many scan positions at that time we scanned it in parallel. So, but I wanted to show the onboard registration is working brilliant, and you see also the detail of the scan data. So the achievable accuracy, even with hundreds of scan positions, is under 1 centimeter. So that's my last slide. It's a member of EKG Baukultur, and I tell one operator, one project, one day, one scanner. So thank you very much, and please, Matthias, take over, and I hope you can tell us how to come from the point cloud to the floor plan and to the section, as you can see here. Matthias Ganspöck, thank you.
Yeah, hello. Thanks, Nikolaus, for the very detailed and interesting explanation of how your scanners work. First, do you see my screen in the back? Can you see it? Okay. I simply turn on this and this. Okay, so my name is Mathias Ganspöck. I work with EKG Baukultur, Ziviltechniker, which means we are architects, more or less. Just need to get used to this. So where do we come from? Who are we? In 2010, we were founded as kind of a spin-off of the University of Technology of Vienna. And now, 10, 11 years later, we have 3 offices in Austria and Germany. In Austria, in Vienna, on the east side of Austria, and Germany in Feldkirch, which is in Vorarlberg on the very west of Austria. And one office in Lüdenscheid, which is in Westfalen. We are architects and service providers, and we are specialized in as-built objects of residential, commercial, and industrial use from all periods. And our office, we're quite young, so the average age of the seniors is 45 years, and the team is in average 31 years old, which explains stupid WhatsApp messages I get since 2 o'clock. And as architects, our aim is to preserve buildings and constructions and keep them fit for a sustainable use. And service providers, we work very hard to provide perfect planning basics to colleagues and partners. Our main services are architectural planning, building information modeling, of course, building survey and industrial services, which will be the main focus for this session now, and cultural technology. I don't know if this is the right English term. It's about shaping the landscape and controlling the environment so that there is no avalanches or landslides, wild water, and so on. That's a field where our scanners are really useful and where models are really useful. We have a homepage. It's ekg-baukultur.com. Just go there and get in touch. You can call us, write emails. We're on Facebook with my name or with EKG Baukultur, or Instagram, just all the normal channels that we have nowadays. So our connection to Riegl laser measurement systems is for a long time, more or less, because in the early 2000s, there was this project executed by the University of Technology Vienna and the Austrian Academy of Sciences. And the scope was to scan the Domitilla catacombs in Rome. Not to scan, more to survey it in 3D. It's a huge catacomb with, I think, 500 to 500 meters in square on 4 departments with approximately 12 kilometers of aisles. And that's when the Riegl scanner came into use because we had it at university, and Riegl is a partner that is very interested in helping the clients. Since then, we transfer a lot of knowledge and experience, so we can't transfer so much knowledge, but experience. So we tell Riegl what we like, what we don't like. Sometimes they like to hear it, sometimes they don't. in general, we get a really cool feedback. And in my eyes, we were this really small company, and a big company like Riegl listened to us and to our demands, what we need to do our job. And I think that's the reason why we profit from this really cool scanning system we can use right now. And that's something that we are very, very thankful that we can work together with the manufacturer of the tools that we use to do our job. So I want to talk about the workflows, because Mr. Studnicka was talking about the technology, about how it's working itself. And I'm a user of that scanner, so I can tell you of the workflows we use. I'm sure there is other workflows or better workflows. I want to present how we do it, and I think we do it quite good because we work a lot. That's also the reason for the wall in the back. For anybody's wondering why I'm not in the office, I'm in Styria at the border to Slovenia at the Castle Ehrenhausen that we're working on this the mausoleum of the people who lived in this castle right now. So that's the reason for that wall. Our offices don't look like this. And I will tell you about the 3D scan of an object, the registration of the single scans, the post-processing in Rescan Pro, the export of the scan data to PointCab, and the import to the CAD application of your choice, Revit or Archicad or AutoCAD or BricsCAD or whatever is used. So all of the manufacturers tell us that it's super easy to do the scans, just like Mr. Studnicka did a few minutes ago. So they tell us that we simply mount a few of these targets, that we put the scanner and that we do scans, and then we have automatic registration processes, and that everything works like magic. And yeah, this is not so true. So we fix plain registration targets, coded registration targets, registration spheres, reflector targets, and so on. Because we're not only a user of a Riegl scanner, we also have scanners of other brand, which needs targets like this or spheres. And what was really a bummer for all this work was the time it consumes to mount these targets. So when you have a little project with a few scan positions, this is not much of a problem. You mount 10 of these targets, or you mount some spheres, and that's it. But when you want to scan a whole monastery or a big castle or a huge office building, it takes a lot of time to mount these targets and to unmount them again too. We still get calls from a hospital in Vienna that we scanned, I think, 10 years ago, that they still find these targets and if they're allowed to remove them after 10 years. Well, in these photos, it looks like fun, but it's no fun at all, because you need to climb towers, and you need to glue them to walls that have been plastered recently. So it was really important for us that this task of scanning hasn't to be done anymore. And so to say, it's not so easy to do the scans because you need to do some preparation work and so on. And then you see this, and during the registration, that's what we want to have. We want to start with a scan position here, and do a second one here, and the third one here, fourth, fifth, sixth, seventh. And then we want to do the registration, and then we want to have a perfect point cloud with no shifts and rotations and so on. But with most of the automatic registering processes, you get something like this sometimes. You get rotated scans, translated scans, shifted scans, scans that I don't know why it happens somewhere in the nirvana, but not where they belong to. And the adjustment algorithms were really great to optimize these things, these block adjustments Mr. Studnicka was talking about. But sometimes they made it even worse. And that was, so we started wasting time with mounting all those targets. And here we continue wasting time, because as soon as this happens, we need to do manual work in the registration process. Because we can't leave it like this. of course, we ignored this sometimes, because when you have 10 scans of a room interior and one is not right, it's okay. You can work around it. But sometimes it doesn't work, and so you need to go back to the software and correct the registration. And this is also okay for scan projects with a few scans, like 100 scans, 200 scans, because you can spend some time and do a manual correction. But it's not okay if you do 100 of scans per day, because you lose a lot of time in the office in the end of the day. And the cool thing is, using the VZ scanner, for us, these problems here are really in the past, because we don't face these problems anymore. The auto registration works really surprisingly well, we import hundreds of scan positions to the Riscan Pro and tell it, do a registration. Of course, sometimes it fails, and then you need to tell the scanning software where a single scan needs to be put. But we found out that it's mostly operating errors rather than software errors. So Mr. Studnicka was telling that you have a certain amount of time from one position to the next one. Then GPS, of course, is a issue. Good reception, bad reception. But if you take care of some basic operating steps and rules, you're really safe that automatic scan registration, even for hundreds of scans through different departments, interior, exterior, works quite well. And for example, scanning this here would take us 7 scan positions, and we can do it in 10 minutes. I must confess, I didn't listen if Mr. Studnicka told how long one scan position takes. But for us, one scanning position with including acquiring the images needed for the that are done with the scanner is about 45 seconds. So we can do 7 scan positions in 10 minutes because we need some time to carry the scanner from one position to the next position. Which is a huge benefit for us, because we can do a lot of scans every day, and they're registered already with the new version. But even if they're not registered after one day, it's an automatic routine to the registration, so we don't lose time with this. As you can see, we are architects, we are not surveyors, we are not 3D scanner fans of whatever kind. We want to do plans, we want to do models, we want to do orthogonal drawings and so on. So this really helps us that we can concentrate on what we learned and what we want to do and with what we earn our money with, and we don't need to take care about scan registration, failed registrations, and so on. This is really a benefit for us. So for those who don't know Riegl scanners, or who work with different scanners and want to know what's to be done after you scanned, I want to talk a little bit about assessing and filtering the scan data. And there is kind of a one-click routine, so you can set different filters and different manipulations that need to be done to each scan position. And what we do is we filter by the deviation values, by reflectance values, isolated points, by range, and target count. Reflectance is important because we can more or less, and deviation also in this connex, because we can get rid of windows as glass or of points that are not very well scanned, you know, like ghost points that are around. And usually this gives us a great point cloud with very low stray points, very low noise, and not so many points that are somewhere flying around, disturbing the work that we need to do afterwards. After registering the scans and filtering, we use the Geosys manager Mr. Studnicka was talking about, and transform the scans into a coordinate reference system of our choice. So if we want to use WGS84, it's okay. If we want to use a UTM, it's just a few clicks that it's transformed to there. In Austria, we normally use Gauss-Krüger, and the meridian 28, 31, and 34, and we can transform the data to there. And as we've learned before, the data is georeferenced by the with the help of the GPS correctional service. We use APOS a lot. It's the Austrian positioning service. And so in most cases, for example, this castle I'm right now here, it's on top of a hill. There's nothing around. So if it's 2 centimeters more to the north or to the east, no one cares, to be honest, and it saves us a lot of time so that we don't need to do a survey with a tachymeter starting at the church which is in the valley behind me. So we can rely on the GPS measurement that we have a very good and very precise georeference. And in the end of this process in Riescan Pro, we mostly create a point cloud copy of each scan, and we dump a lot of metadata that the Riegl scanners save to a scan. This simply to save us storage requirements, because as you can imagine, we work a lot with the scanners. We do 400 scanning positions each day. We order hard drives and we order server space on a weekly basis, more or less, because there's so much data that needs to be stored and put to somewhere. If you're interested in this metadata the scanners save, you should really refer to Riegl, because that's something very unique and something really interesting for these scanners, because filtering processes or data cleaning processes are much more, you can do a lot more with it, because most scanners give you XYZ coordinates, RGB value, and the reflectance, but nothing more. And these scanners give you a lot of measuring values that you can use for visualization, for filtering. And we even can show a wet wall compared to a dry wall as a very simple example. And that's cool about these scanners as well. So, but for drawing plans or doing a 3D model, we mostly keep reflectance and true color. These two values, because reflectance is a super value for really see something, because a lot of times we are in attics where there's no light, so true color doesn't help a lot. We are in basements where there's no light, so true color doesn't help us a lot, because we've got millions of black points. So the reflectance is a good value so that we can see what we're working on. So after we exported so after we finished our work in Riescan Pro, we come to PointCab, which is one of the reasons why we are here now. There is one step we still need to do. It is that we need to export all the scans in LAS format at the moment, because at the moment, and the people at PointCab are working on it, I know it, PointCab can't import Riescan Pro project files like they can with Leica or Faro files, because we lose the coordinate reference system, and which wouldn't be too good. But I'm sure they are eagerly working to fix that. And it's no problem, because we simply export the scans from Riescan Pro and we import them to PointCab, so it's not much of a deal. But you need to take care, because the Riescan Pro, and when you take a coordinate reference system, a geodetic coordinate reference system, the X and Y coordinates are switched. So the data comes to your CAD application mirrored, because we as engineers from the architecture, we have a X coordinate and a Y coordinate, and we have a height, a set value. And the surveyors, they have easting, northing, and the height, and that's the other way around, which again is absolutely no problem. You could fix it in Riescan Pro already. So you do a copy of the coordinate reference system and you can switch the coordinates just as you like. We leave it like it is, and we mirror it back in whatever software we use in the end of the process. So we import the scan data to PointCab. This looks like here. I think that most of the people who are here are PointCab users, so they might know what's happening within PointCab. So you import the scan data, you get this really nice rendering of your point cloud data. Then you can, in the most easy way, you can set vertical and horizontal sections. You can do you've got a lot of other tools like this delta tool, which is really cool because you can do kind of a map of the relief of your scanning data. You have got a possibility to, so if a wall is not straight like this, but you have a wall like this, you can put a section that follows your wall and you can make an orthogonal unrolling of this wall, which is really useful. So there's a bunch of cool features that you can use to more or less translate your laser scanning data from the laser scanning software to make it editable for any CAD software you want to use. And of course, you can use it as a 3D viewer too. But that's something that people from PointCab should explain to you more in detail, because I don't want to tell anything wrong about this right now. So in the end, we can export all of these sections and then floor and horizontal sections to any CAD software you need, and this looks like this. When you've done this, this is AutoCAD, for example. It's a 2D plan of an old villa from the 19th century, and then you get it in the right scale, and you just work on it as you work on any plan. And there's some detail. There's two ways of getting these images that lie behind, or that are put behind or that PointCab produces. There's these orthophotos, which is more or less a tiled rendering of the images. So you've got dozens of little tiles that will be imported to AutoCAD, or you can do one single TIFF file, which is a merger that puts together all these little tiles to one vector graphic. We don't face any problems anymore with a contemporary computer to import one single large TIFF file to AutoCAD or Archicad. And for me, or for us, it's the easier way, because you don't have got hundreds of little tiles. You've got one image that is XREF, and that's okay. But you need to try this if this works for you or not. And Mr. Studnicka was telling about a software before. It's called Pano. It gives us the possibility, because that's something we use when we are working on these plans. You need to know all the height values, all the coordinates. You want to have a look into the scan data, and maybe you don't want to fall back to PointCab again. Or what we do, because we've got these 3 offices which are apart from each other 700 kilometers, it gives us the possibility to put our scanning data very easily onto a server. I can show this to you here. So this was what Mr. Studnicka was showing before. This is on the server. It looks like this. You can get Google Earth images. You can get Google Maps to it, so you see that all that registration is right and the georeferencing is right. And when you want to, for example, within the church, there's some detail you can't read properly from this top view. We have it on the server. You click on it. It downloads the panorama image, and then you can have a look onto the reflectance value. You can change this view to the photos, for example. It's a little bit dizzy because it was very dark, and we didn't change the way the pictures are taken, which is an operation error, not a device error. You can have a look at the colored point cloud, and you can do, of course, measurements, whatever you want to do. And one cool thing about this software is that sometimes, for example, when you're working on vaults like this, it's not so easy to understand the geometry. So what the people at Riegl gave us was the possibility to do sections and sections within this online viewer. So you simply make like this, and then you tell the direction you want to look at, and then you generate the section. This may take some time because it downloads now all the data, and then it does an orthogonal projection of the scans that you did, and that's totally enough sometimes to put it to AutoCAD or to better understand what you are doing. Or when you are just like us architects and you have a meeting on the construction site because it's about doing a renovation to this door in the back or to these arches. You're in the office, you do this, you simply print it out on A4 or A3 paper, and you can take it to the construction site. And you have got a cool basis for doing sketches or for doing notes and so on. This is a feature which is really, really helpful for us in our daily work. So, and the good thing is, as we told, this works for us in any scale. Earlier we used, for example, a bigger scanner for the large areas in the exterior, then maybe a phase shift scanner for the interior, or a structured light scanner for building details of these medieval structures. But this is not necessary anymore because this one device is, of course, no structured light scanner in terms of detail, but it's far enough to do plans up to a scale of 1 to 5, which is very okay. And so we have one scan that we can do very quickly. We've got one project on the computer, and then we can take out a lot of data to do plans, models, and so on, which look like, yeah, I'll show you later on. So this is one monastery with the surrounding area, because here should be a underground parking, and there should be a new roundabout, new streets. And so we could do one data set for all of the people involved in this big project. This also works in a city scale. This is the old town of Villach in Carinthia. We've started scanning all of the old town. This is a work in progress. These scans are public, available in the GIS system or the town map of Villach, the official map you can look at online. So we've got this one system with which we can do a city or a big monastery or one church or one building, always with the same level of detail and the same accuracy, and it helps us doing plans like this, where we don't lack any detail, so we can draw these accurate to shape plans, but this in as a section, so it's not only horizontal, it's also vertical. And of course, as I've been telling, we can do also models out of it. This is one part of UT, as University of Technology of Vienna. It's the building 221. It's where people who learn to build cars have their laboratories and so on. And yeah, this is really convenient. And in the end, we are really fast. And so I think it helped a lot to more or less establish a sense of that laser scanning is not an expensive or not an complicated way of doing building surveys. And so due to the fact that it's not so expensive anymore. So normally, even if our clients only want the church or only want the monastery, we go there and we do all of the building because it doesn't take much more time, and we've got all the data on the computer. And in our experience, a year after a project here, there will be a project here and a project here. And we want to draw plans and do models, but we don't want to sit in the car and travel through all of Austria the whole time to do scans like this. So we scan it all because it's not much of an effort for us anymore. We have it on our server, and when there is a demand for a plan of this part of the monastery, we can simply do it without the necessity of going there and scan it again. Yes, so that's in principle the end of my presentation. So if there are any questions, I would be happy to do a little discussion or just get in touch with us and ask you questions. Thanks very much for your attendance here.
Yeah, thank you two for being here and for holding this presentation. I think we got a lot of insights, a lot of in-depth insights, so that was really nice. So to all of you who are still here and listening, now is your time to ask some questions. You should see questions or a chat tab in your GoToWebinar panel. So just go ahead, type in whatever you want to know. We have 5 minutes left, but I guess if it's going a little bit longer, I hope Nikolaus and Mathias won't run out on us. I hope they will stay 5 minutes more if necessary, if there are some questions. Okay, so I have the first question now. How much does the whole system cost in total? The scanner, VZ400 plus Panos software. Are there possibilities to rent it?
Yeah, we are a manufacturer. We want to sell the instrument, and the standard price for the in Europe for the scanner itself is 56,500 plus camera and camera mounting, some software and so on. The software license for Panos is 1,700 euros. But please, you know my email address, and of course we can write an offer if you like. So we do not rent it, we present it. So if you want to have a test scan, we would be happy to show you the scanner live wherever you are.
I rent it. If someone likes, you can have it for a day or two. And no, just kidding. We need it every day. There's something about the price I want to tell, because the price is really high. But the Riegl scanner was the first scanner we bought where I didn't miss the money so much, because I think if you think it of a business, for each euro you spend, you should earn back 5 euros. So the more your system costs, the more you get back in the end of the day. So it's a tool, you need it, and it's really worth it. So
yeah. Okay, any more questions? Please don't be shy to type in. We will answer all the questions. Okay, so I have the next one. Hi, is there a necessity to send the scanner for calibration once a year?
So after 2,000 to 3,000 working hours, we recommend to send it back, or after 2-3 years. Usually it's not necessary to recalibrate. It's super stable, and you will see immediately if you drop down the scanner super hard or so, you will see in the multi-station report, which is a very detailed report, that something happens, and you can check it by yourself by control points. How good is the scanner? But so after, let's say, 3 years or so, we recommend to check it in the office, but there is no must to recalibrate every year.
Okay. And then I got the next question just now. What is the weight of the device?
It's a good question. The scanner itself is 10 kilograms. So we have a camera on top with another 1.5 kilo, and it depends on the battery. We have also 1 to 2 kilogram for the battery. So it keeps stable even the wind is very high, very strong. But I think it's no problem, Matthias. One of your colleagues, he can manage 400 scans per day easily.
Yes. No, it's really not so much of a problem in my eyes, but I'm not so much scanning. I'm very much in the administration of this company. So it's there are lighter scanners, but you know, it's for example, when we worked at Südbahnhof in Vienna, the construction site of the railway station. It was a railway station from 1955 that was totally demolished to do a new railway station in 2011. And when you're there in the sand, and there is the excavators around you, and the trucks going, and I don't know, police calling you off the construction site all 2 hours because they found a bomb from World War II. You're really happy if you have a tough system. And it's cool because it's more or less, so in our experience, the system is more or less waterproof. So it can rain quite a lot and it doesn't affect the scanner. It affects the camera a little bit, but it's okay to say that you're pretty safe also in tough conditions. Sorry.
Yeah, so I got right now I got a lot of questions now. So first question, hi, can you use the camera for capturing HDR panos?
So the camera is a Nikon camera, D850. You can create HDR images. Yes, our customers are doing in this way. You can use the standard camera as it is. Yes.
Then I got another question in German. I'll try to translate as good as I can. I hope that's okay with you, Mr. Offenhuber. So you explained that in Repano you can leave out the heights, but he's asking if you can put the whole project on 0. Because he thinks otherwise he would you know, have to translate and calculate every single measurement, and he thinks that's really you know, that's really complicated. Did you get the question?
I think Mr. Studnicka knows the question already.
Okay.
Yes, there is a demand to have an update for Repano, and it's super powerful. But yes, we implement one feature after the other, and we should implement new functions as well. I know.
Okay, so that's on your list at least.
Yeah.
Okay, great. And then another question again about HDR settings in color. They were asking what about HDR settings in color, 3 times HDR and 5 times HDR, because you mentioned some problems with color inside Repano. Are there any problems, or does this work?
So if you take HDR photos and you take several images, then we recommend to do the photograph after the scan process. So the camera is fixed, stable in one direction. You take the pictures, and the camera calculate all the images together. I showed the high-speed mode to take only one picture. So that means in 45 seconds you get all your images at the same time. But if it's at night, for example, Metropolitan Police in London, they have tens of our scanners in the police car, and if they take images at night for car accidents and so on, they use the camera in a very stable way. So first scan and then take the pictures. You lose a little bit time at night, but then it's one of the best cameras on the market to get a good picture of black motorcycles in the night.
I can add something to that in the field use. I think it's a real. Everybody's asking about HDR pictures because most of the scanners give bad colors because they've got these industry cameras built in, taking 70 little stamp-sized pictures and so on. with this system, you work with a Nikon or a Canon camera, a normal mirrored camera, or I hope soon the Z7 series will be mounted to the scanner with a mirrorless camera, and you can work with it like you work with a photo camera. So if you are if image quality or color is important for the project, you can operate the scanner like you operate a photo camera and take perfect pictures. So if this is important, it's not so important for us in most cases, but that's one cool thing, that you don't have it's a you know, you've got a professional photo camera on top of your scanner, and you don't have a little camera built in like in your mobile phone, and with very limited possibilities of taking a picture. You have the full range of taking pictures just like you need. And that's a good thing. It was a very good thing today, actually, because we got changing sun conditions, because the weather is quite nice. Now it's not so nice anymore, but you know, it's clouds and sun and clouds and sun, and so you can change the camera settings very quickly if you are not too unexperienced with a normal photo camera, and then it's not a problem at all. Yeah.
Okay. Is there an example for the Repano web solution for exploring it online? For exploring it online. Okay. So I guess they're asking for a trial version of some kind.
Well, we could we do a link to our homepage, so people could maybe in the evening check back to our homepage, and then there's a link to the. We've got one data set of the zoo in Vienna, and the zoo in Vienna is the top tourism attraction worldwide. So it's the mostly, together with Castle of Schönbrunn, it's the mostly visited attraction. So it's definitely worth to click it and then to have a look at it.
Right.
We have one example on our website, Riegl.com, if you enter at the terrestrial laser scanning section.
So if there are no further questions, I think we are already 10 minutes above what we actually plan to do for the webinar. So I guess that is okay. As you already mentioned, I guess people can always reach out to you with any questions they have and just ask you directly. We've seen your contacts. If for some reason you can't reach them directly, you can always reach out to PointCab as well. We will refer you. And I hope you all really liked this webinar today. I think it was great in my opinion, and I hope to see something like that in the future. Again, thank you very, very much, Nikolaus and Matthias, for taking the time and being here and showing what amazing work you do. Okay, so last word goes to you. Anything to add, you two?
Thank you, Nicole, for the host and for inviting us and to give us the possibility to talk. And hopefully we can repeat it next year and show you the next developments. Thank you, Nicole.
Thanks.
Thank you, guys. Thanks. Bye.
Bye-bye.
Bye.
Bye-bye.